Okay. You should have in front of you your power notes of solving two-step and multi-step inequalities. And our essential question today is, how do you solve these types of inequalities? I would hope that some of you have already got some ideas in your head, and those ideas hopefully are correct in that all you have to do is solve them just like a two-step or a multi-step equation. So we're looking at chapter 2 pretty much being the same thing. Okay, so we do have to remember something, that to solve just like equations, except remember to flip the sign when you need to. So when do we flip that sign? So let's remind ourselves, we're going to flip that sign when we multiply or divide by a negative number. We have to not forget that, by a negative number. That is when we're going to end up flipping the sign. As long as we remember that part, we're good. Another thing I'm going to introduce you to today is how to check your solutions. Okay? So let's kind of get started. We're going to do 3 problems and we're going to check. We're not going to graph at this point. If you notice, all of your examples say solve and check. So that's what we're going to do. So let's take a look at this first example. And this first example on solve and check says 5x minus 3 is greater than 12. So this is kind of set up just like a two-step equation. So what we're going to do is we're going to add 3 to both sides. And then we're left with 5x. And adding 3 doesn't touch that inequality, so it brings it down. And 12 plus 3 is 15. So again, we're isolating the variable just like a two-step. So we're going to divide both sides by 5. Now, does dividing by 5 flip the sign over? No, it does not. So we leave it. And we have x. And this becomes 3. Now, how do we check our solutions? Well, we're going to check our solutions as if this inequality doesn't exist. We're going to use an equal sign to see if it's going to work. So 5 times 3 minus 3 equals 12. And again, we're going to follow those order of operations to make sure what's going on. So 5 times 3 is 15. 15 minus 3 is 12. And since both sides check out, then we know that x is less than 3 is our solution. So we need all the numbers less than 3. 2.5, 2, 1, negative 500, whatever those numbers are, those will make all the numbers that make this true. And just as a reminder, you don't have to do it on this assignment unless it tells you to, but if you got a graph, remember to put a 0. This one needs a 3. We want open circles when there's no equal sign, so open circle, and this is less than, so it's going to go to the left on forever. Okay, we don't have to graph in our notes today, but if in your homework you do, just a little reminder about how to graph. Okay, let's do it again. This time we'll get at something a little more involved. We have negative 4 times x minus 1 is greater than or equal to 8. I'm going to draw a little line down the side here because that might help some people. Now there are 2 ways to do this problem. So let me see if I can, let me duplicate this. I'm going to show you 2 different ways to do it. So let me get this one over here and this one here. Okay? Oops. All right. The first way would be the normal way that you guys normally would do, is you would distribute, correct? So I would say negative 4 times x is negative 4x. Negative 4 times negative 1 is positive 4, greater than or equal to 8. Okay, let's continue with this one, and I'll show you another way in a second. All right, so then our next step would be to subtract 4 from both sides. Again, that doesn't touch the inequality, so we get negative 4x is greater than or equal to 8 minus 4, which is 4. And then the next thing we would do to get that x alone is divide both sides by negative 4. And by dividing by negative 4, that's going to flip our inequality sign over to the other way, and we're going to get x is less than or equal to negative 1. So you kind of see the steps, and that's what we're with at the moment. I'm going to just leave that there. Okay, I'm going to see if I can get through here like this and show you another way before we check. Or let's check. I'll flip over here and check. So negative 4 times negative 1 minus 1 equals 8. Remember, we're going to put an equal sign in. So a negative 1 and a negative 1 is a negative 2. And a negative 4 times negative 2 is positive 8. We'd have to do the check either way that we were going to solve it. Now I'm going to show you a little bit of a shortcut. Okay, I want you to think about this negative 4 times this whole thing. It's kind of like having negative 4x equals 8, right? When we got the x alone, what did we do? Divide both sides by negative 4. Is that correct? We're going to do the same thing here. We're going to divide both sides by negative 4. What that does is it stops the whole elimination of me distributing. Since there's nothing else here, only this distribution I have to do, I can cut this off early. Cut it off early and get rid of it. And then that makes my problem even simpler. X minus 1, and 8 divided by negative 4 is negative 2. Remember, it went from positive to negative. That means we got to flip that sign over. Okay? And then to get that x alone, I would just add 1 to both sides and find out that x is less than or equal to negative 1. And again, we got in the same place. Less work. I still did it in 2 steps, but I had to distribute first, so that's really 3 steps here. So it's up to you which way you want to do it. But there's an idea, and it only works if these numbers are divisible. Okay, and what do I mean by that? Because this was a 4 and this was an 8. 4 can go into 8, so we could do this. If this was a 10, I would not advise it because you would get a fraction, and then you're just subtracting fractions from whole numbers. It's crazy. But this is a great shortcut if this number on the outside of the parentheses can divide into the number on the other side of the sign. So something to think about. You don't have to do that way. It's always safe to stay this way. This works every single time. This one you have to really watch what you're doing, but it's a nice shortcut for those people who might want to take it. All right, last example, solve and check. This time I have a fraction. 2/3 x plus 1/2 is greater than 1/3. So we have to remember from chapter 2. Remember we talked about least common denominator. So I have a 3, a 2, and a 3. My least common denominator is going to be 6. So what I'm going to do is I'm going to multiply everything times 6 over 1, just like we did that other time, right? And I'm going to simplify it. So 3 goes into 6 2 times. So I have 2 times 2 times x, which is 4x, plus 2 goes into 6 3 times. So 1 times 3 is 3, greater than 3 goes into 6 2 times. 1 times 2 is 2. A lot cleaner. Let's continue. We're going to subtract 3 from both sides. And we get 4x. Now subtracting 3 doesn't change the sign. Even though this goes from positive to negative, we're just adding and subtracting. The only way that happens, changes, is when we're multiplying or dividing by a negative number. And then we're going to divide by 4. And we find that x is greater than negative 1/4. And we're going to have to check the fraction, and that's okay because things usually work out. So I'm not too concerned about that. So let us check what's going on. So I have 2/3 times negative 1/4 plus 1/2 equals 1/3. Well, let's simplify over here. 2 can go into 4 2 times. So I'm going to simplify this by multiplying. 1 times negative 1 is negative 1. 3 times 2 is 6. Now I can't add negative 1/6 and 1/2. I have to put it in terms of 6. Remember, the denominators have to be the same. So 2 goes into 6 3 times. 3 times 1 is 3. Now that my numerators are alike, negative 1 plus 3, that's 2/6. And doesn't 2/6 reduce down to 1/3? Sure does. So this is our answer. Remember, checking is only going to help you with the number. What you need to do is always go back and check, did I multiply or divide by a negative number, just to make sure that you don't flip the sign over. So you've got some tricky questions out there that may show up on homework. Just go slow. Remember everything that you know. Like we said before, how do you solve these inequalities? The same way we did two-step and multi-step equations.